Hello, should I turn the camera towards me? All right. I don't know if that's going to, can you see me from your end there?
Yes, I can.
All right, the back.
Frighteningly close.
A little close.
Say that word. A little close. Anyway, we're going to talk about sets of numbers. We talked about sets in class. We're going to talk about kind of those big universal sets of numbers that you talk about all the time. So get out your notes, kids, because I'm going to be checking to make sure you take notes. So you can watch the whole thing and then come back and take notes, or if you want, you can pause. Just don't pause me in a weird position. But take notes. And this is going to be about sets of numbers. So there's a good title for your notes. Sets of numbers. There are a whole bunch of different kinds of numbers. All the numbers you guys have learned about up to this point are real numbers. You haven't learned about any numbers that aren't real, which is interesting. In a couple of years, you'll learn about some numbers called imaginary and complex numbers, and they're not real. But this year, we're going to stay in the real number system. So, real numbers are every number you've ever met up to this point. There's a special little symbol that denotes real numbers. It's kind of a fancy R. Sometimes it's an R with two bars like that. Okay? All right. So, real numbers is every number you can think of. Give me a real number, Mr. Haas.
7.
7 is a real number. These are all examples.
How about like a fraction, like a third?
Sure.
Is that all? Really? How about like
a real number.
pi?
Pi is a real number even.
Really?
Isn't that crazy?
That's crazy.
Every number you can think of is real.
Square root of 2?
Square root of 2 is real.
Wow.
0 is real. In the olden days, it wasn't really even considered a number.
How about negative 2/3?
Negative 2/3. Any number you could possibly come up with is a real number. Okay? So that's our big category.
That's a lot of numbers.
That's a lot of numbers. I'm going to make that our big universal set. Our big universal set of numbers I'm going to call the real numbers. And here's some examples of real numbers. Okay? I'm going to erase that. And we're going to talk about a subset of the real numbers. And that subset is a gigantic subset of irrational numbers. Irrational numbers. All right, what's an irrational number, you might say? Well, an irrational number is a number that's not rational.
Good explanation there, Ms. Stewart. Wow.
In other words, an irrational number is a number that you cannot write as a fraction of two integers.
How about like 5? That's not a fraction.
But I could write 5 as
5 over 1. Oh, so
cool?
5 is rational.
5 is rational.
Right, I get that mixed up sometimes.
I know,
all right.
But there are some very famous irrational numbers, like pi is an irrational number. Because I can't write that as a fraction of integers.
Isn't there some fraction I remember learning, way back that it was some fraction, I don't even remember, 20, yeah, something like that.
Yeah, 22/7 is
that's
pretty
not pi?
darn close to pi, but it's not exactly pi.
Oh, so that's just like a rough estimate.
Absolutely.
I see.
Even the decimal, 3.141592653589793233846, etc., even that's just an estimate. Irrational numbers are, when you turn them into decimal form, they go on and on and on for infinity.
I see.
And there's no pattern, no repetition. That's what makes something irrational. So, Mr. Oz, give me another irrational number.
How about 1 point, are you with me? 1.12, 112, 1112, 11112.
Oh,
You see where I'm going with that?
Yeah, so that's going on forever. No repeating pattern.
Now there is a kind of pattern there.
There's a kind of pattern,
But it doesn't, the whole thing doesn't repeat because you can see that I'm adding one more 1 every time.
Exactly.
So it's not a repeat. In other words, I can't take a chunk of it and kind of lay it on top of the rest of it and get a total repeating thing.
Exactly.
I see. So that works, huh? All
You
right.
know what generates lots of irrational numbers? Square roots.
Ah.
Square root of 2 is irrational. If you oh my goodness, if you threw that in your calculator, you get something between 1 and 2, but a decimal that goes on and on and on, like this one goes on and on, with no pattern. Square root of 5, well heck, you can even have negative square root of 5, irrational number.
How about like square root of 16? Does that work?
Square root of 16 does not work.
Ah.
That's rational. Why? What is the
It
square root
is?
of 16?
I don't know. I get that mixed up
It's
too, Miss.
4.
Oh,
That's
that's
a nice
right.
number. But let's go to rational numbers. Thank you for that segue, Mr. Haas.
Well, I just, I wasn't sure if like everything in a square root is irrational. or not.
No.
Oh, I see. Okay.
Yeah. We're going to talk more about that later.
Miss Stewart, I'm really learning a lot here.
Yeah, I'm sure you are. Okay, so over here will be our rational numbers. And rational numbers are numbers that are not irrational. But of course, all of these are still real. Rational numbers actually have their own little abbreviation. It's actually Q, strangely enough. Q for quotient.
Ah.
Because rational numbers, as we were saying before, are numbers that can be written as a fraction. So, Mr. Haas, as you said before, 5 is rational, because I could, if I felt like it, write it as 5 divided by 1. Negative 2/3 is rational. 1.3 repeating is rational. Now, that's a decimal that goes on and on and on and on forever, but it has a pattern. If I wanted to, I could figure out what fraction went with that.
Because like 2/3, if I wrote that as a decimal, that would be one of those repeating ones too, wouldn't
You're
it?
right. Very nice. Look, this would be negative 0.66666. We write that with a bar over it, if you remember. That's a repeating decimal. I could even have a fraction that's not a repeating decimal, but just, 1/2 or 0.5. I could even have a really, really long decimal, but as long as it stops, boom, as long as it stops, that's rational.
But if it kept going, and no pattern, no repeating pattern, then it would be irrational.
It'd be irrational.
Now, you couldn't just stick, couldn't I stick like pi over 3 or something like that? That doesn't make it rational?
Now, if you go back to what I was saying, a rational number is something that can be written as a fraction using integers.
Ah, so you got to have like a whole number value sitting on the top and a whole number on the bottom. You can't just like stick an irrational number over 5 and get a rational number.
You're right.
All right, I got it.
Beautiful. Are we good?
I'm learning so much.
I know, Mr. Haas. Isn't this fun? Okay, let's just put a couple in here. We've got our integers. And integers, those are nice and easy. Those are kind of like your positive and negative counting numbers plus 0. They have a shorthand too. Integers starts with Z in German. Zellen or something like that in German. That's where the Z comes from. Integers are just your counting numbers. Plus 0. Positive and negative counting numbers. And those go on and on and on forever. I think you can agree that those are all rational numbers. Okay. There are other sets of numbers too. There are even integers, odd integers. Let's just make a list of some of our even integers. Usually when you say even, you're not talking about the negatives, okay? But believe it or not, 0 is an even integer. Why the heck is 0 an even integer? Any ideas, Mr. Haas?
I guess when you divide by 2, you don't get a remainder, perhaps?
You are very smart.
Thank you.
That's exactly right. An even number is just a number that is evenly divisible by 2, and 0 is. Odd integers. These are all terms that you pretty much know, but we're going to bandy them around a little bit this year. Okie doke? So make sure you have all the symbols for all of these numbers in your notes, and that you have a sense of how this kind of diagram works. If you have questions, come see me. Bye.